Hi and welcome to my channel, and in this video I'm going to do a tutorial on how to solve this Zhisheng 3x3 egg. Now this puzzle is actually quite complicated to solve for someone who's never solved it before. I would equate it to the difficulty of a 3x3 ghost cube. Now the ghost cube has certain difficulties that this puzzle does not have, whereas this puzzle has certain slight difficulties, I guess you could say, that the ghost cube doesn't have. Basically, on this one, you could get three types of false equivocations, as I'm going to go through as I do this solve. So in solving this, it's presumed that you know how to easily solve a 3x3 cube. You should preferably also be able to solve a 3x3 master morphics and perhaps other 3x3 shape mods. And okay, so let's begin. So the first thing, when I solve it, the first thing I look for is you can see these center pieces like right here. This one on top and this one bottom, they're like very long, and this is like the long side of the egg. Basically, you could see like these are kind of short and these are short, so I look for the long ones first, and I start with one of them is going to be my top and one is going to be the bottom. So into these long ones, I know that I need to put in these pieces right here. You see these big ones? So I slide one in to where it fits. Now I'm going to have to try to connect this properly to one of the centers. So the way I do it is knowing that this is going to go here. So first I bring it to the bottom and I kick it out. And I keep rotating the center to see if I could put it in. Rotate it like this. And I see I got lucky very quickly. It actually went in right away. And I turn it back to connect with the top. And so we have the first piece in. Now, this might actually not belong here because it's going to be determined by when we put in the second one. It might actually not fit in. We have to swap it to a different place. So we'll see. So we see that in this position, we're going to have to put in the other big piece that faces the other way. Now we have four of these big pieces. Two of them on the bottom and two of them are going to be on the top layer. So let's look for the other ones. We have one right here. Start into the bottom layer and just see it's not going to belong here because it actually goes in upside down. So this one does not belong there. Or this one, yes. So this one is good. So we put this one into the bottom layer, kick it out, and we rotate the center to see if we could fit it in. See, it does not fit in. Kick it back out, rotate the center, put it in, and we got lucky. And we put it in. Now you could have a situation where it would not fit in anyway into the center, and then what you would have to do is basically you would have to reconnect this piece to a different center, possibly this one or that one, and once you place it in into a different center, then this piece would fit in next to that one. So you could have that kind of situation. In this case we got lucky, it went in right away. And next we put in the smaller pieces into these edge positions. And those are going to be these pieces right here. And so place it into the bottom. And we position it to see where it's going to fit. I see this one. You see it's going to come in right here. Comes in. And actually got kind of lucky. It went into the center the right way. Right away without even kind of noticing. So this one we got in very easily. We have another piece right here. Let's see if that one's going to go there. So we put it into the bottom layer. And notice when I put it into the bottom layer, I put it the right way in. Like we have one right here as well, and this one is upside down. So it's going to be more difficult to position it from the bottom. You could also position it into the center like from the side like this. For me, I find it easier to position it like from the bottom. This is our top, and we're connecting it on the bottom. Okay, so we turn this final center to try to connect this. And I don't think it connects there. Let me double check. No, my mistake. Now, actually, this piece just doesn't belong there because actually, if you put it in, you see it's upside down. So this is one of the bottom layer pieces. So this one is no good there. That's why it didn't fit in. We have another piece right here. So I bring it into the bottom layer, the right side up. And it connects actually to the center right away. Turn it in. And you see we have our cross. Next, we put in the corner pieces. So let's start, doesn't really matter which one we start with. I guess let's start this the tiny piece belongs here. We actually have the huge piece here. But this piece belongs here. And you just do the simple, movements to put it in. Right here. back. Now we have this big piece here, so let's put in the big piece into here. Basic 3x3 stuff, put it in here. This one, and the more you solve it, the more you kind of see right away which one goes where. And I see this one is not gonna go here. It actually belongs here. And so let's put that in. And the last one, this one does not belong here. And this one does, but we have to kick it out, bring this down, put it in, return it, and we have the first layer fully solved. Turn the cube upside down as we would do with the 3x3. See, this piece is already in. This one is already in, so kind of getting really lucky with this solve. This is one of the top layer pieces, and so is this. Okay, so this piece, we have two types of pieces in the middle layer basically. We have this type of piece, and we have this type of piece. So this one has a trapezoidal piece, and this one has this kind of I'm not sure what you would call, like a rhombic kind of shape or something. So this one, we want to try to keep this piece last, and the reason is in order to avoid one of the false equivocations, and that false equivocation is where when you do the top layer, one of the edges could possibly be flipped. 3 of them are flipped right, 1 is flipped wrong. Technically on a 3x3 that's impossible, but the reason this happens here is because this piece right here could be flipped either way when it's put into the middle layer. It has 2 possible orientations. This trapezoidal piece could only be put in one way, whereas this one could be put in 2 ways. So if you have a situation where one of the pieces on the top layer is flipped, that means this piece needs to be taken out, flipped, and put back in. So let's see. Okay, so we basically position it to see which one goes where and see, test it out. This one does not go in from here. If we put it over here, we bring it down, it does go in. So we have to put it in from the front going down towards the right. Do the simple 3x3 algorithm. U, R, U, I, R, I, U, I, F, I, U, F, and that puts it in, and we have the last piece. Now when putting in the last piece, the way we test it to see how we have to put it in is we look at this piece, which is going to come out, and we see, for instance, if we put this in from this side like this, then this piece is going to come out like this, and so when it comes out, it's going to be facing right side up like this. So we know if we put this in from here, this one is going to come out facing right side up. So we look at the other ones. We see this one is right side up. Let's see. No, actually, this is not one of the pieces. We're going to be putting in this piece. My mistake. This one. Okay, so we look at that one is right side up. This one is upside down. This one is upside down. So we have 2 upside down, 1 right side up. So we want to put this one in a way where this one comes out right side up. And the reason is because if this one comes out right side up, we're going to have 2 right side up, 2 upside down. So that's normal situation. It's not a false equivocation. If, however, we were to put this from here, this one is going to kick out upside down, and we're going to have the false equivocation. So let me do it just to show you how that happens. I'm going to do it wrong on purpose. So put this in from here. U, R, U, I, R, I, U, I, F, I, U, F. Okay. So let's see. This one is right side up. This one is upside down, upside down, upside down. So basically, you see we have only one that's flipped right. And if we try to fix that, we're going to end up with one that's flipped wrong. So you see if you do the standard algorithm, F, R, U, R, I, U, I, F, I. Now you see these two are good. This one is flipped right. This one is upside down. So what we need to do is we look for one of these pieces, we bring it out, we flip it, and we bring it. So the way we do it is as such. We want to put in any of these into this position. Doesn't matter which one because we're going to bring it back out. So what this is going to do, when we put this in here, this one is going to go back there. Once it's back there, we do a 2U to bring it up front. We do the same algorithm to put it back, and it's going to put it back flipped. Okay, so put this one in here, and this one is going to get kicked out there. U, R, U, I, RI, UI, FI, U, F. That one is back there. Do a 2U to put it here. Now it's going to come in flipped. Now we're not going to see that it's flipped because, like I said, this one has two possible orientations once it's in the middle. But it's going to solve the false equivocation. U, R, UI, RI, UI, FI, U, F. Puts it in. First two layers are fully solved, and you see all the pieces here are properly oriented. We could have avoided that by simply putting it in from the left side, as I showed you earlier. Next step is I see we have another false equivocation, and which is one of these edges belongs on the bottom. It has to be swapped to the bottom edge. The reason is because you see we have two. First of all, they're all flipped properly. Second of all, you see two are connected, two are not. Whenever you have a situation where two of them are connected, that's a false equivocation, because if we recycle them over and over, we're going to continue getting situations of two of them being connected, or all of them being properly placed in conjunction with one another, but the center is going to be rotated 90 degrees. So we need to switch these out, swap one of these edges with one at the bottom, and each one of these edge pieces has an equivalent bottom edge. And the way we do it is the same way I showed with some other videos that I have. And so let's say we want to do this one right here. So first we see which one is its equivalent. Is it this piece? Turn it in. You see it comes in, so it is. Okay, so we're going to swap that one out with this one from the bottom layer. So this one we have on the bottom, on our right. This one we place on top, front. From this position, the first setup move, do an R turn to bring this here. Second setup move, we do a UI to bring this here. And the reason we do this is we're going to do the algorithm that puts this in here like this. And we want to put it in the right way. If we were to put it in from here, it would come in upside down. So we want to put it in from here. This one is going to get kicked into the top layer. So we do the algorithm from here, which is UI, FI, U, F, U, R, UI, RI. Swap those two out. Next thing we want to do is we kicked out this corner piece, which is now back there. So we do a 2U, place this in, and we're going to flip this properly by doing RI, DI, RD without returning this face from this position, RI, DI, RD. So RI, DI, RD, RI, DI, RD. We check it. It's flipped good. We replace it with some other edge piece, whichever one, in order to fix the bottom, because we have to do RI, DI, RD 3 times, as you know. So let's put in this one and flip it twice. RI, DI, RD, RI, DI, RD, RI, DI, RD, RI, DI, RD. Put back this piece, bring it back down. Now we have to fix this edge piece, which we kicked out before, which is right there. So we do a 2U to place it here and put it in from the right, going down like this. And from here we do UI, FI, U, F, U, R, UI, RI. Bottom layers are fixed, and we've gotten rid of the false equivocation. As you could see, well, you can't really see it yet. So what we're going to do first, we're going to see this one is right side up, this one is right side up, and these two are flipped. So let's flip these back. We have the L. So we do, what do we do? F, R, U, R, I, U, I, R, U, R, I, U, I, F, I. And they're all properly flipped now. This one is here. And so from here we do the soon algorithm. And it should put them all in the proper places. Okay, so R, U, R, I, U, R, 2U, R, I. And we see we have the cross on top. We could orient the top face to match up with the bottom. And we see, let's see, we do not have a corner false equivocation, because we see we have one corner in, and we have, basically, these are all not in their proper places. So it means if we cycle them, they're going to go into the right places. And I have another video on my ghost cube on solving the third layer of the ghost cube, where I show how to deal with the situation if you do have two swapped. In this case, we don't have that situation, so the way we do it here is we just simply do the regular corner cycling algorithm, which is U R U I L I U R I U I L. Now we simply orient them R I D I R D R I D I R D R I D I R D R I D I R D. Put in this one R I D I R D D I R D, and again R I D I R D R I D I R D. Put on the last one R I D I R D R I D I R D R I D I R D R I D I R D, and we have ourselves a solved Zhisheng egg. And yeah, so hopefully this is going to be helpful to those who watch it. Should you have any questions, feel free to ask, and thanks for watching.